So for topic two, we are going to continue the very slow, arduous journey of building this unit circle. So let's define what a unit circle is, okay? So the unit circle is a circle with a radius of 1 centered at the origin. So in math, when you see the word unit, frequently it means 1, okay? Now there's units like feet, inches, miles, and so forth, but a lot of times when we talk about a unit, think 1, okay? So a radius of 1 centered at the origin of the Cartesian coordinate plane. So again, just regular Cartesian plane. Origin is the center of your circle and it has a radius of 1, okay? It's a fundamental concept in trigonometry, okay? And in the previous video, we talked about this idea of similar triangles and how the trigonometric functions are the same on similar triangles. That kind of bleeds in here. So imagine you drew a circle centered at the origin with some random radius. Let's say the radius was 10, okay? And you built all these triangles in there that had these really common angles. So 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, or not 180 degrees for a triangle, but you built all these triangles, okay? And then you just figured out what the trig functions were. Well, imagine doing that and then building the exact same circle. It's just in this case, instead of having some random radius, you had a radius of exactly 1. Okay. That radius of 1 is going to make our lives a lot easier. Okay. So that when we do find these ratios, they're just going to be easier to work with because the denominator is going to have a 1 in it. Okay. So we do need to remind ourselves of a couple of things from pre-calculus. Okay. First up is the definition of a circle. So go back to your pre-calculus days and remember that when you're dealing with a circle, if you're centered at the origin and you have a radius of 1, the formula for that or the equation for that would be x squared plus y squared equals 1. Okay. And we've been kind of dancing around that in previous videos, but we're here to say the unit circle is defined by the equation x squared plus y squared is 1. Every point on that circle, so you can kind of see a unit circle down here. We have a circle centered at the origin with a radius of 1. If you chose any point on that circle, it would satisfy this equation. So it would have some xy coordinate that represented that point. You plug it into this equation, you would get a true statement, okay? Now, theta is an angle measured from the positive x-axis to some point on the circle, okay? So you can kind of envision this. We've drawn so many angles at this point. So envision you've got your vertex at the center, or at the origin rather. You have your initial side on the positive x-axis. In this case, to get to this point that we have drawn on this circle, we would sweep open in the counterclockwise direction. And we're going to intersect this circle with our angle, but when we intersect the circle, we're going to cross some point P that we're now calling xy. Okay, so no matter what size angle you draw on this unit circle, you'll intersect the circle somewhere at some xy point. Okay, and it doesn't matter which xy point you choose. If you were to plug it in here, it would satisfy this equation. Okay, so let's talk about some really, really important points on the unit circle. Let me see if I can shrink this a little bit. I don't want to shrink it too much to the point where we can't see. Okay, it's going to be easiest if we start with x and y intercepts, okay? And you're going to see, hopefully, really quickly that x and y intercepts match up to really important points on this circle, or not really points, but angles, okay? So if we start with let's do these in purple. So if we start with our x and y intercepts, our first intercept is going to be right here. It's an x-intercept, and it's going to be the point 1, 0. So this is where the circle crosses the x-axis, okay? And our next one is going to be a y-intercept, and it's where the circle crosses the positive y-axis. It's going to be the point 0, 1. And then we have this one here, which is the point negative 1, 0. And then we have this one here, which is the point 0, negative 1. So those are really important points. And believe it or not, you already know these points. We've talked about them a couple of times. So when you're building this idea of angles, so angles that live in this circle, if you have a situation where the initial side and the terminal side lay on top of each other and we never sweep out the terminal side, we would just have 0 degrees. If we make it all the way to the positive y-axis, we have 90 degrees. If we make it all the way to the negative x-axis, we've traveled 180 degrees. And if we make it to the negative y-axis, we have traveled 270 degrees. And if we were to draw an angle that goes all the way around the circle, one full revolution, okay, we would have traveled 360 degrees. Okay, so those were what we called our quadrant angles. Okay, and on a unit circle, they have really, really great points. Okay, so the point on the terminal side of one of the quadrant angles in the unit circle, it's all going to be zeros, ones, and negative ones. Okay, so if we have theta of 0 degrees, then the point P is going to be 1, 0. Okay, so we go out 1 on the x-axis and we don't go up or down, so we're at 1, 0. Now, if we go to the point where we have theta is 90 degrees, we have the ordered pair 0, 1. To get to that point on the Cartesian plane or on the circle, as it's drawn in the Cartesian plane, we would never go left or right. We don't leave the origin, we just go up. So we have a distance of 0 on the x-axis and then a distance of 1 on the y-axis. Now, if we were to go over to 180 degrees, we would have the ordered pair negative 1, 0. So from the origin, we would go to the left 1, but then we don't go up or down to be on that point on the circle at exactly 180 degrees. Now, if we were to travel 270 degrees, then the point P would be 0, negative 1. To get to that point, it would just be never going left or right on the x-axis, going down negative 1. But remember, we're actually drawing an angle. So imagine drawing the angle that does basically this. It travels around the circle and it ends here. Okay. Now, if we were to do one full revolution, so we start at the end of the circle and then we go all the way around, we know that's 360 degrees, and that takes us right back to where we started from. So the point 1, 0. Now, just for funsies, let's remember, if you're going to draw a negative angle, so negative angles open in the clockwise direction. So if we were interested in negative 90 degrees, let's kind of draw that. So I'm going to draw a separate circle so we don't get too clogged up here. So we have our Cartesian plane. We're going to try to draw a beautiful circle. It's not nearly as pretty as the one that's printed, but let's pretend, okay? So we have the origin. We're going to have, let's draw a different color for our angle. So we're going to have the vertex at the origin, our initial side right here, and then we're going to open in the clockwise direction and we're going to go 90 degrees. So if we were to travel 90 degrees on the unit circle, this would be the point 0, negative 1. So for negative 90 degrees, that would be in the clockwise in the clockwise direction, and we would be at 0, negative 1. Now we could keep going. We could do negative 180. We could do negative 270, negative 360, but you hopefully get the gist, okay? Now also remember that we have radians too, so this would be 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, 2 pi radians, negative pi over 2 radians. So don't forget that we're going to, truthfully, I need to draw that angle better. I just realized that my angle is not particularly, pretend this is exactly 90 degrees. It looks a little, it's a little crooked, y'all, okay? Anyway, so just remember that we have degrees, we have radians. We're actually going to be dealing with radians probably a bit more in this course, so don't forget them, embrace them, and love them for what they are. Okay, so we're slowly but surely, we're building this idea of a unit circle. So just remember, a unit circle is a circle that is centered at the origin and has a radius of 1. And that radius of 1 is going to be magical for us very, very soon, okay? And then just know your quadrant angles and what point we would have on the unit circle for each angle that is a quadrant angle, okay?